Good morning, guys. We're back with another problem. Today's problem is the partitions with a given difference. So this is a DP-based problem where you have to be good with subsets and the shortest and the longest subsequence of arrays. So what you can see is that we will be given an array and partition it into two subsets possible, such that each element must belong to one subset, and let the sum of those elements of those two subsets be S1 and S2. We will also be given a difference D. Count the number of partitions in which S1 is greater than or equals to S2, and the difference between S1 and S2 is equals to D. Since the answer may be really long, we can give it a modulus 10 to the power 9 plus 7. Okay, so here are two examples, so I will explain it. Present. Yeah. So before I start with this problem statement, first I would like to explain this problem statements. So we have to know some formulas. So some formulas are, I will write it over here, some important formulas. Just a second. Yeah, some formulas. So the first formula is this: can represent. So number of ways we can represent numbers. So there is a formula for number of ways we can represent a number. So the formula is equals to power of 2 comma n, okay, cross multiplied by the answer. So say for example you have, if the number is 2, right? So if the number is 2, say n equals to 2, what I can do is I can do 2 to the power of 2, as 2 square is 2 comma n is 2 to the power 2, into, suppose I have only 1, so I can have 4, which means 4 possible ways. 4 possible ways. Okay. So next is like this, that how this can be used. So say for example I'm taking an array 0, 1, I'm taking an array 1, 0, I'm taking an array as 0, 0, I'm taking an array as 1, 1. So you can see that 1 can be represented in many ways. Okay, 1 can be represented as many ways, or like so and so. So this is how number of possible ways we can do. This is a formula. Okay, this formula we may require in this particular statement based on our needs, we may not require. Okay, so now let's analyze the problem. The first problem is basically telling that you are given an array. So first I will take the array as ARR equals to, I will take the array as 5, 2, 6 and 4. Okay, now my next target is the difference. So I will also be given a difference D equals to 3. So how I can make this array? So first target is divide this array into two subsets. So when I'm dividing this array into two subsets, what I can get is one array is 5 and 2. Okay, so this is the condition of the question. Don't think I'm doing this purposely. And the other array is 6 and 4. So when I'm doing the 5 and 2, what I can see is I have to take the sum of this difference, sum of these elements. So this element sum will become 7, and for 6 and 4 the element sum will become 10. Now you can see the absolute difference. If I calculate how much it is coming, it is 10 minus 7 is equals to 3. Okay, so there is only one possible combination. There is only, suppose say for example if I take 8, 4 and 2, say for example if I take these two elements, this and this, okay, it will add to 8, and then this and this, it will add to this. So we can't do like this, right? So we have to get a maximum difference of 3. So total number of possibilities in which we are getting a maximum difference 3 is only 1. So this will nothing be but our output. But over here you have to be very careful that this difference has to come out which is equals to this particular difference. Okay. So let's see some conditions which are given in the question. So the conditions which are given are like the conditions are that this value S1 should be greater than or equals to S2. So what S1 and S2 are basically? So this is one subset S1 and this is one subset S2. That is saying that this subset, the subset value, okay, should be greater than, or S1 should be greater than or equals to S2. Okay, this is one condition. The next condition, do we have any other condition? Let's see any other conditions are there or not. So this was one condition, and they have also given a condition, the S1 minus S2 is equals to D. So if you see, the difference between 7 and 10 is 3, which is equals to D. So this is also one condition. So these are one conditions which are fulfilling. Okay, there should be also one condition. So that nums of I should be nums of I. So which are the numbers of the array. So say for example, you have an array this and an array this. So there are say elements over here in this array. So x1, x2, xi, xi1, 2 dot dot dot. There are so many elements, right? So they are saying that the nums of I, the name of the array is nums of I, should be greater than equals to 1, okay, and less than equals to 1000. So these are the test cases. These are the test cases constraints. Okay, this has to be followed. So what next we can see? Next we have to derive a formula of the, like, how we can implement this is our coding. Okay, right? So for example, we have been given the formula. We have been given the formula as S1 minus S2 is equals to D, right? So I can write it over here. Before doing that, I can write it over here. Just a second. Yeah. S1 minus S2 is equals to D. In what other way I can write this? I can write it like this, that S1 is equals to total sum minus of S2. Okay, and I can further write it like this. I can derive this formula like this: total sum, okay, minus S2 is equals to D. Okay, or I can further write it like this: total sum minus D equals to 2 into S2. Okay, and from there, if I want to compute this value of S2, what I can write it further as S2 equals to total sum minus of D by 2. So this is our formula. Okay, so this formula, what does this formula help to do? So this formula is nothing but count of the subset. Okay, so using these formulas we are going to do. So our first task is also we have to keep in mind that total sum has to be greater than 0, which I have already told, and total sum has to be an even number. Okay, also I will be starting from a given target value equals to 0, means that is the start. So whenever you are encountering target equals to 0 or index equals to 0, which means starting from first value. Okay, so these are the conditions required. So long story short, if I explain the story, there will be one array. I have to divide this array into two subsets, S1 and S2, where S1 greater than equals to S2. Also S1 minus S2 is equals to D. D will be given in the question, and S1 and S2 is there. Okay, and you can write it like ARR dot 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 till 10. Okay, so we will be solving this problem using dynamic programming, plus we'll be also using a concept of recursive tree. Okay, so recursive tree is like say for example, you will have a function. There's a lot of codes over here. You are recursively calling this particular function again. So this is a function which has sub functions. These functions are calling themselves again and again and again. So this is how we are making a recursive tree. Okay, so we'll come back to that later on. So now let's go with the coding part. Okay, so first we can see there is a method called count partitions. Okay, but before doing the count partitions method, I will write the method of count partitions util. Okay, so first I will take a mod value. Okay, this is a global variable, static mod equals to int. Okay, int. I will take math.pow of 10, 9, because in the question it is given 10 to the power 9 plus 7. So I will write it over here plus 7. Okay, this is our main function, but before that I'm going to make a static counter function. So count partitions static count partitions util. Okay, so this is the name of the function. Over here I will take an int of index, I will take int target value, I will take int an array. Okay, and then what I will take a DP array to store the elements in the DP table. Okay, DP array should be two-dimensional array. So people are often ask me one question, that why do we write it as DP third bracket. No, you can write it as XYZ, any variable. DP is just there to just make you remind that no, you're solving a DP problem. Okay, so next what you're going to do is if we are going to check, we are starting from the starting value. As I told, if index is equals to 0, what we are going to do, we are going to also check if target is equals to 0, and then ARR or 0 equals to 0, return 2. Okay, so this was one if condition. Also over here we are going to check if target, say for example, if target equals to 0 or target equals to error of 0, we are going to return 1. Okay, so first we have checked the if condition. Okay, then we have checked the if to return 1 and then return 0. Okay, the final if to close. Okay, next what I'm going to check is if the DP of index and target not equals to -1. Okay, then what I'm going to return DP of index and DP of target. Okay, now I'm also going to take a variable for those elements which are not taken. So I will write it like this. Int not taken equals to, I will recursively call this function count. Okay, and I will pass the parameters. I will simply pass the parameters in -1, so the index is going in the backward direction, target ARR in the DP table. Okay, now there will be also variable int taken equals to 0. So if ARR of index lesser than equals to target, what I can write is taken equals to, I will recursively call this function and I will pass the value in -1, target minus ARR of index ARR DP. Okay, lastly I'm going to return DP of index target, these are the indexes, is equals to not taken plus taken modulus of mod value. So this is, the answer has to be divided using mod value, right? So you will take a percentage modulus. So we have closed this function. Now we are going to write the code for the main function. So what we are going to write for the main function, we are going to take a total sum value. So int say total sum equals to 0. I am going to traverse the list from I 0 less than n plus plus tot sum plus equals to ARR of 5. Okay, now I'm going to take tot sum minus d less than 0. So if it is lesser than 0, which is a base case, so I can write it like this as base cases. Okay, so where are the base cases? You can see 0 less than equals to D less than equals to 25,000. So the base case is you have to check the total sum, the difference. Okay, so the return 0 is already calculated. Now what we are going to do is we are going to check dot sum minus D is an even checker. I already told you that the sum modulus 2 has to be an even number, so equals to 1, then we will return 0. Okay, so just quickly check. Okay, modulus 2 equals to 1, yeah, return 0. Okay, once this is done, I will take the S2 equals to, I will use this formula. Now what is the formula for S2? I'm going to quickly go over here. The formula is total sum minus D by 2. So I will put the formula over here, total sum minus D, okay, by 2. Now I'm going to put the values in the DP table, equals to new int the size of the rows and the column S2 plus 1. Okay, for loop there will be a loop of row in the DP table. They will fill up the DP table like this. Okay, so in the DP table I can write arrays dot fill. I can fill the values row comma minus 1. Okay, lastly I'm going to return the particular function which is given below. I will pass the value n minus 1 S2 array and the DP table. So this is okay. So let's compile. Static mod equals to okay, so identifier accepted. Static int mod. Okay, in line number 102 if dp, so dp, okay, how is this an illegal startup statement? Index and target. Let me check. I've taken the dp array. Okay, if dp so I cannot just put 2 equals to right here. Let's check. Yeah, so this was a pretty hard problem of recursion. So we'll be writing the points. Recursively call. So today we have completed 100 days. That's a big milestone. 100 days. Recursive call. But in my YouTube channel, I guess I have completed around say 65 days, because previously I had to do it without the YouTube. So make sure you subscribe, and in case of any queries, there will be you can always ask me. Okay, so this was today's problem about the maximum partitions with the given difference. And in case you're wondering, this is the mathematical computation and the ways in which we have calculated the difference. Okay, so we are looking forward to see you in our next video. Thank you.